So in this video, we'll see how to build a simple neural network model to solve the regression problem. So let's first import the libraries required. Import TensorFlow. Then let's import NumPy will require, and let's import pandas. So that's it. These are the three libraries which will require. So after we have TensorFlow in place or imported, so we'll create our own data set, right? We'll create sample data set. We'll not use any big data set, at least in this video. We will use a very simple data set which will be created by us only. So let's say data is equal to, I'll first create a NumPy array which will start from 10, let's say, and which will go till let's say 500 or 100, right? And the step size will be 5. That means, if I create this, you can see, that data set will look like this. If I print data, so you see we are starting at 10 and going till 100, right? When we in NumPy, when we create array using NumPy, when we say this is we want to go till 100, this 100 will not be included, right? That will be excluded, right? So 10 to 100 with the step size of 5, right? So 10, 15, 20, 25, right? So that is data. So we'll need one more array. Let's say that is data1 equal to np dot. Now this will be starting from 20. Again, it will go till 110, and with the step size of 5, right? So that is data1. Now, so these are two NumPy arrays. Now from these two NumPy arrays, we'll create a tensor. We'll create two tensors. First tensor is x is equal to tf dot constant, and to that we'll pass first NumPy array, and y equal to tf dot constant. Right? These are the two tensors now. X and y are now tensors. They are not NumPy arrays now, right? So now if we print x will look like x comma y. If we print, they will look like this. Yeah. Now they are tensors with the shape of, the shape of tensor x is this 18 comma y. It's a one-dimensional tensor. Y is also one-dimensional tensor. Now with this, let's try to build our first model. Right? So first the neural network model. So model equal to tf dot keras. Keras is the library which was built for creating this neural network models. Now that the Keras is integrated in TensorFlow, so we'll be using Keras, saying tf.keras dot sequential. We want to create sequential. We want to build sequential model. And to this, now in this, right, in this we'll be passing how many layers we want in this model. Actually, sequential means there are layer of sequential layers of the neural network. That's what the sequential means, right? So there are layers of neural networks. That's what the sequential means. So now let's in here we'll be putting how many layers are there, right? Now let's say, right. So I'll be writing how many layers we want to have, right? So tf dot keras dot layers dense. Layers are dense. This layer is dense. Layer means fully connected layer, right? So, and how many neurons we want, we'll write in the bracket of dense, right? So we would like to have only one neuron, so that's why I wrote one, right? tf dot keras dot dense, keras dot layers dot dense. So this will add a layer with one neuron, right? Let's say we have only one neuron here for now. Let's say we have only one neuron here. So what we did here, we created only we created a layer, right? So this, this is a layer. So this step basically is building the model, right? Building the model. That means here you specify how many layers you want, how many layers you want in neural network, right? So layer 1 or layer 2, layer 3, so on and so forth. You specify how many layers. Now here we have added only one, this layer we have added, right? Right. And also you specify how many neurons you want in each layer. In this layer we have only one neuron, right? So that architecture you define in the first step. In the first step you say what type of model it is. It's a sequential model. That means you have one layer after the other, and in these brackets you specify, right, the layers. There is only one layer here, right? So you can here you can, there is another way to add the layers, but here we are adding the layer in the sequential itself, right? In this bracket itself. Otherwise, you can add layer after this line also by saying tf.keras.sequential and close the bracket, and then you can say model.add layers and all that, right? But here we are adding the layers here itself, right? Okay, so now as we created a model with one layer, let's try to let's try to the second step now is to compile the model in the so model dot compile. Second step is compile the model, and in compile you specify what is the loss function. Loss is equal to tf dot keras dot losses dot. There are different types of losses. We discuss MAE and MSE. So let's take MAE, mean absolute error. And here you also specify what is the optimizer. Optimizer means you specify how your model learns or how your model improves, right? Optimizer is equal to tf dot keras dot optimizers. So here there are various optimizers like SGD, Adam, Ada Delta, Ada Grad, etc. So let's take SGD here, and also you specify what is the metrics you are using to measure the performance of the model. Metrics is equal to, let's say, MAE. Same metrics will be using MAE. And then finally, in the final step, you fit your model to the data. So that means you run your model on the data which we have. So model dot fit, and what is the data you want? We have x comma y, and you specify for how many epochs you want to run this model. Epoch means in one epoch model goes through all the data, right? For example, if I say in epoch 1, if I say, let's first write epoch is equal to 5. So when I execute this, right, in one epoch, what happens is in one epoch model goes through all these x's, right, all these x's and y's, right? All these x's and y's in one epoch. In the second epoch, again model goes through all these x's and y's, right? Okay. So now if you see the relationship between x and y here, you see y is equal to x plus 10, right? You see y is equal to x plus 10, right? So I guess we created same x and y. So let me change that. So our y should start from here we made a mistake here, data 1. So it should be y should be data 1. Y should be created from data 1. Data 1 is the numpy array which is starting from 20 and going till 110 with the step size of 5. So now x and y, if you see x and y, so the relationship between x and y is, you see, y is equal to x plus 10. So you see, this is equal to this plus 10, and this is equal to this plus 10. So that's the relationship between x and y. And our model will try to figure out this relationship. What is the relationship between x and y? You see, this is a linear regression problem, right? So if you plot this graph, you will be getting a straight line like this here on x and here on y, or here y and x. Get this straight line, right? So this is a linear regression problem. Our model will try to figure out this relationship, and if you give unknown x, for example, if you give now x's we have, we'll train our model, we'll give our model this x, and we'll also give y, right? We'll give this x and we'll give this y. We'll give this x, we'll give this y, right? So you will give each pair, right? Each pair. And by a model, we'll try to figure out what is the relationship between x and y. Let's hope that model will try to figure out this relationship. And when then that, and now to our model, we'll give only till 90. Only these many values we are going to give. And if we give to our model 200 as x, so model should predict y as 210. That's what we want. That's what we want, right? Okay, let's now try to see whether our model, yeah, let's, and this is called as, here we are fitting the model, means we are executing our model on this x and y data, and epochs means five times the model will see all the x's and y's. Five times we are going to give feed this x and y to model. Model will improve each time, let's say, right? Let's try to run this. Now you see you got an error here. So what's an error here? The error is because you see error, right? Error. So error is because of the shape of the input, right? Now you see the model is expecting a 2D data, right? If you see x here, x is looking like this. If you see, let me print x first. So if I print x, x is a 1D data, but or I'm sorry, our model is expecting x to be like this. It is expecting x to be a two-dimensional data like this, right? So this is like this, right? 15 and 20, like this. Model is expecting this kind of data, right? But we are giving this 1D array, right, as input to the model. So that's why we are getting this error. So let's try to improve our model now or by let's try to change the shape of x. So how can I change the shape of x? X is equal to expand tf dot expand dims. We want to expand the dimensions of whose dimensions we want to expand, x and comma axis. Axis, what axis you want to add? We have to add the axis in the big end, right? So x is equal to -1. That, so now if I print x with this, so you'll see you get this kind of shape, right? Yeah, right. So now that can be fed as input to our model, right? Let's now feed the input, this input to our model. So same model, model 1 now, tf dot keras dot sequential, and to this, in this we'll be having only one layer, tf dot keras layers dense 1, only one layer and only one neuron in that layer, right? Now model dot compile, model 1 dot compile, and here we will define the loss. Loss is equal to tf dot keras losses dot mae, then optimizer tf dot keras optimizers would be having SGD, let's say, and then we'll have the metrics MAE, and now finally we'll fit our data model to the data model one dot fit x comma y comma epochs is equal to, let's say, 5. Right, now let's run this model. Model 1 is not defined, right? Model 1 okay, we made a mistake here, spelling mistake we made. Model 1, right? Model 1. Okay, you see, model has gone through this data. This in this epoch, model went through the data once, and while training, we've got a loss of 14, right? And then, in the next epoch or in the next iteration, when we again trained the model, we got a loss of 16. Then loss increased here, and then loss 9 and loss 18. Now let's see what's the prediction our model is making, right? If I pass 200 to the model, what kind of prediction it makes? Let's see, right? So model dot predict, model 1 dot predict. Let's say we pass 200, right? So model is giving 207.9, and that means approximately 208, right? So not bad, model has learned. We have trained model in a good way. So we expected model to predict 210 because we saw that for y is equal to x plus 10, right? Now let's improve our model. Now what are the steps to improve our model, right? So in here, if we see our model, right, we can improve our model by uh, in in all these three steps we can improve. This is step number 1, this is step number 2, this is step number 3. In step number 1, what can we do to improve our model? We can add more layers here, right? We have only one neuron. Now I can add this is we have only one layer here, layer 1. I can add the layers here, right? I can add the layers here, right? Right, or and also I can increase the number of neurons in each of those layers, right? So that's what I can do. In the output layer, I need to have only one neuron because we expect only one number as the output, right? That's why in the output layer, I need only one neuron. Okay, so in step 1, we can increase the number of layers as well as number of neurons. That's what I can do. That is called that's what I can do in layer 1. Sorry, in step 1. In step 2, what can I do? I can change this optimizer. I can change this optimizer. That optimizer says how your model can improve, right? I can here use Adam, and also I can improve. I can change the learning rate here, right? In the bracket of this SGD, we have what is called as learning rate. Learning rate. I can change that if it is 0.01, I can make it 1, 0.001, etc. Right? So these two in step. Let me write these steps to improve. In in step 1, we can increase the number of hidden units and number of layers. In step 2, that is here compile step, we can change the optimizer and the learning rate here, right? That's what we can do here in step 2. In step 2, in order to improve the model, we can train it for longer and on for more data, right? So the data here is hardly 18, 19 values we are giving here. So we can increase the size of X or data set X and Y. And that one thing, we can increase the size of data. And other thing is we can train it for little longer. We train it only for 5 epochs. We can make it to 50 or 100 epochs, right? Okay, so we can improve the models by altering any of these steps, this step, and this step, right? Or we can try to alter all of these steps, right? Okay, so now let's try to build our next model by changing the number of layers here by adding more layers here, right? Let's build the second model here. Model 3 will have here model 2. Model 2 is equal to tf.keras dot sequential, and now tf.keras layers dot uh, let's say we will have dense layer here and one neuron. Now in the we'll have one more layer here, tf.keras, again one more layer, right? Now one more thing we can do here here is we can change the activation function here, right? So here I can change the activation function, activation to, let's say, relu, right? Okay, that's one more thing which I can do, right? So we have added one more layer here. Now let's compile the model, model 2 dot compile, and loss tf dot keras dot losses dot mae, and optimizer tf dot keras dot, let's say, sgd, and in here I can specify the learning rate. Let's say learning rate is equal to 0.1, and then I can say what is the matrix MAE. Now let's try to fit the model to our data. Model 2 dot fit x comma y comma. Now we'll train it for a little longer. Box is equal to, let's say, 50, right? Okay. So now let's try to run this model. Yeah, loss. Let's now try to see what is the prediction. If you see loss is almost 57. That means this new model is not performing better than the previous model, right? So let's try to model 2 dot predict. Let's say 200. Okay, sorry. So here you need to give it as an array. Okay, it's performing really weirdly, right? So it's giving something, right, random number, some random number, right? So model 1 was better. Model 1 is better than model 2, right? Because you see you have a bigger loss here in model 2, right? So that's how you can try to change these parameters. These are called as hyperparameters. So you can try to change the number of epochs, you can try to change the size of data set, you can try to change the optimizer, the learning rate, then you can try to change the layers, add more layers, add more hidden units. So they are hyperparameters, right? The parameters which we can change, which can vary, they are called as hyperparameter. So you can do that. So that's it for this video. We saw how to build a model and how to improve it. So the second model which we built did not perform well, but you can try yourself to by changing these parameters here, by changing the layers, hidden units, the optimizer, and the data set, size of data set, and the epochs, right?